Welcome to our first example of looking at the comparison and the limit comparison tests for infinite series. So in this question, we're asked to determine whether the series is going to converge or diverge. Well, one thing that we can do is to maybe get an idea or an impression of this is to kind of look to see what happens to the terms as they start to get very, very large, so as they go off to infinity. Well, if we look, we really have something like 5 over the square root of 25 n squared minus 7. As n gets very, very large, then this factor of negative 7 that we have in the denominator really starts to not matter so much. And so what happens, this thing really starts to basically look like 5 over the square root of 25 over times n squared, which for that, we just have basically 5 over n, or simplifying it even more, like 1 over n. So as n gets very, very large, then this thing is really going to look like something that resembles 1 over n. And so our idea maybe is that probably won't want to maybe compare this to the series n goes from 1 to infinity of 1 over n. And for this one, we know that it's a divergent p-series. And so this gives us a good idea of what we can compare it to. And so now let's take a look at exactly what the limit comparison test is really saying. So in the limit comparison test, we have two series, a series with terms a sub n and a series with terms b sub n. Now, what we need in that series is what we need in this test is that for our series with the terms b sub n, these things have some kind of known behavior to them. And so this thing is going to behave some way for which we can know and predict, and we use that to then infer information about the other series. Well, in our previous analysis for what we did in there, we said that the terms of the series that we were given, that we did an analysis on those terms and said these things are basically going to look like some kind of known p-series, and in particular, the known p-series was really just going to be our harmonic series 1 over n. And so for this one, we know that it's a divergent p-series. In particular, it's our harmonic series. So we know that this thing is going to diverge. Well, if we then turn around and look at the limit, so we want to look at the limit as n goes off to infinity of our a sub n's over b sub n's. So that's going to be our limit as n goes off to infinity of our term, so 5 over the square root of 25 n squared minus 7 over our term 1 over n. So that's what we're going to compare this thing to. All right, well, if we do some algebra on that, we look at the limit, n goes off to infinity. So we've got 5 over square root 25 n squared minus 7 times, now n over 1 for that thing. So if we do keep kind of doing the algebraic simplification on that, let's see what happens. Is going to be equal to our limit as n goes off to infinity, our 5n. Let's make that a little clearer, shall we? Our 5n over the square root of 25n squared minus 7, which if we kind of square the top, we can rewrite that. Limit as n goes to infinity of 25n squared let's erase that. So 25n squared over 25n squared minus 7 inside our square root. And so kind of rewriting it like this, we can see now that the inside, so our inside is going to be a rational expression where the numerator, where the degree of the numerator is equal to the degree of the denominator. And so that tells us that in the limit as n goes off to infinity, that our 25n squared over 25n squared minus 7 is going to approach 25 over 25, or 1, as n goes off to infinity. So the inside, we know, just because it's a rational expression, heads off to 1. And so that means that the limit of the square root, since it's a continuous function, is just going to head to the square root of 1, which is 1. Okay, so now by our limit comparison test, so this thing is not 0. And so what that means, by our limit comparison test, and because our series converge to some place in between 0 and infinity, so we have some finite value there, we're actually in this case, so we're in that finite value, and so that tells us that the series are really going to converge at the same rate. Okay, so kind of the punchline is that the series, or the terms of the series, go to 0 at the same rate. So since they go to 0 at the same rate, that tells us that the limit comparison test is then telling us that the behavior, so that the behavior for both series is the same. So since our series, 1 over n goes from 1 to infinity, since this series diverges, then our series, we were given at the beginning, so n goes from 1 to infinity, 5 over the square root of 25 n squared minus 7, also diverges. So I hope this has been kind of informative, and I'll see you guys in the next example.